Lesson 8.2, we are going to go into the world of integer exponents, and you'll notice here I've indicated negative exponents. The reason I say that is because our exponents have negative signs on them on this particular case. We're going to simplify expressions with integer exponents, and we're going to evaluate the zero exponent. So the reason, again, negative exponents, they're technically integer exponents. The reason I'm using the term negative is in this particular case is because you'll notice that the power itself, in this case, the exponent has a negative sign on it. The thing to realize is that just because this is a negative sign on it does not make the whole number a negative, okay? In this case, the negative is simply a notation, okay? If we wanted to make the whole thing a negative, we would have a negative sign out in front, all right? So just keep that in mind. Just having this negative here does not make the whole number negative. And in this particular case, all this negative sign does is give us a fraction. Okay, so when you see a negative exponent, you need to think in your head fraction with a 1 in the numerator. Okay, so for what our purposes are here in this particular class, and you'll get into more advanced work with integer exponents later, but for now, when you see a negative on your exponent, you need to go fraction with 1 in the numerator. Okay. Then the base number, in this case the 5, and the exponent itself, you're going to drop the negative sign. You're going to put those into the denominator. Okay. And then from here, we can go ahead and simplify further. So again, the negative on the exponent gives me a fraction, 1 in the numerator. Take the base and the exponent itself, drop it into the denominator, and then we'll simplify. And so that's why I'm flipping over to the next screen here, 5 to the negative 4 power. So 1 over 5 to the 4th power. Okay. So then we will just simply evaluate our exponent. And this is a fractional value. That's what our negative exponents do. They give us fractional values. So 5 to the 4th power, we go through the multiplying 5 4 times. So 5 times 5 is 25. 25 times 5 is 125. 125 times 5 is 625. So 5 to the 4th power is 1/625. All right. In B, again, negative exponent, so 1 over my base number, my 10, and my exponent go into the denominator of the fraction. And then I evaluate my 10 squared. 10 to the 2nd power is 100. So 10 to the negative 2 power is 1/100th. All right, 2 to the negative 5 power, 1 over 2 to the 5th. And then evaluate 2 to the 5th power. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 1/32. All right, now, in D, we have to deal with a little bit of notation, reminders, and so on. Remember, as we talked about in the previous section, if I have an exponent, it is only applied to the thing that immediately precedes it. So in this particular case, with the way this is written, okay, this negative exponent is only currently applied to the 3, not the negative sign. All right. If I wanted the negative exponent to apply to both, we would actually put the negative 3 in parentheses. All right. So if I wanted it to, or if we wanted it to apply to both, we would actually write it this way. Okay. So now what we have to do basically is we're going to apply the negative 3 power to this 3, and then when we're all said and done, we're going to stick on the negative sign. So okay, let me change colors back here to this. And so 1 over 3 to the 3rd power in the denominator. Okay. So again, we're going to do all this stuff and we're going to attach the negative sign. And I can actually do it now, but it's just going to be attached to the front when we're done. So 1 over 3 to the 3rd power, well, 3 to the 3rd power, 3 times 3 is 9, times another 3 is 27. Okay, attach my negative sign, and we're all set. Now, if we had this one, and in this particular case, it's going to end up being the same. 1 over negative 3 to the third power. 1 over, that would end up being negative 27. And in this particular case, whether the negative's in the denominator or out in front. So these, in this case, would end up being the same. Where it wouldn't be the same is if this were to be a 4. Okay, because what would happen here is we would end up with 4 negative signs there, and those 2 pairs of negatives would end up being a positive, and all of a sudden our value would end up, one would be a negative and one would be a positive. So the placement is extremely important. So just be careful. I'm going to go ahead and get rid of this now to apply the exponent to the proper items. So then we're going to talk about the 0 power, and I'm going to talk about this. And sorry, I flipped back and forth there a little bit. I want to explore a little bit of patterns, okay, and then I'll come back. I'll flip back to the previous slide of 0 power. Okay, notice here when we have our let me get my good writing tool here. If I have 2 to the third power, I have 8. I have 2 squared, I have 4. 2 to the first power is 2. And even if I go down here to the bottom, fractions, okay, this would end up being 1 over 2 to the first power, 1/2. But you'll notice my 2 to the first power was 2. My 2 to the first power ended up giving me a 2 in the denominator. 1 over 2 to the negative 2 power would be this, because our 2 squared would go into the denominator, and end up being 1 over 4. And you'll notice up here my 2 squared gave me a 4. My 2 squared gave me a 4, but in the denominator. Okay? So then, and go ahead and let's deal with 3 while I'm at it. Similar type of idea. 1 over 3 to the first power, right, which is just 3. So my 3 to the first power up here gave me a 3. My 3 to the first power here gave me a 3. It just happens to be in fraction. 1 over 3 squared. 3 squared is 9. So 1 over 9. And again, 3 to the second power is 9. 3 to the second power is still 9, just part of a fraction. So now we get to 3 to the 0 and 2 to the 0. And this is where I want to explore patterns. Okay? If I work from the bottom or the top down, 8 down to 4. Well, what do I do to 8 to make 4? Well, I divide by 2. Okay? 4 to make 2? Divide by 2. So if I'm going to continue the pattern, 2 divided by 2 is 1. So 2 to the 0 power has to be 1. And if I continue here, 1 divided by 2 is a half. 1/2 divided by 2 is 1/4. And so you'll notice that pattern there, if I use that pattern, 2 to the 0 ends up being 1. Let's see if it works for 3's. What do I do to 27 to make 9? Well, I divide by 3. What do I do to 9 to make 3? Well, I divide by 3. So if I divide 3 by 3, 3 divided by 3, well, that's 1. 1 divided by 3, well, that's 1/3. 1/3 divided by 3, well, that's 1/9. So you'll notice here in each case, the 0 power gave us 1. So 3 to the 0 power was 1. 2 to the 0 power was 1. So if I go back to my previous slide, and this is what the 0 power property tells us, is that any number raised to the 0 power is always equal to 1. Alright, so 4 to the 0 power is 1. Negative 2 to the 0 power is 1. Y to the 0 power is 1. And even if I came up with something 4x plus 6y all divided by x to the 5th power, and then I take all of this and I raise it to the 0 power, all of this raised to the 0 power in the end is going to equal 1. So that actually can be a shortcut for you if you're trying to simplify things. If you have a bunch of gobbledygook and then it's all raised to the 0 power, well, all of that gobbledygook will end up being 1. So 0 powers explored through a pattern, all our 0 powers have to be 1s. So now we're going to simplify the expression, and we're going to use our order of operations to do so. So please excuse my dear Aunt Sally. And remember, when we get to M and D, A and S, we do those things from left to right. So in the parentheses, 4 plus 2 is 6. All right, to the negative 2 power, negative 7 to the 0. I'm just bringing down the stuff that I haven't used yet. All right, exponents next. Well, negative 7 to the 0 power, that's 1. So I know in this particular case that's 1. 6 to the negative 2 power. Okay, 1 over 6 squared. Well, 6 squared, though, is 36. So this is 1/36. 2 plus 1 minus 1/36. Okay, so now I have to, and I have some choices of how I want to deal with it. 2 plus 1 is 3. We add and subtract from left to right. Minus 1/36, which I actually hope you can do on the top of your head. I hope that you realize if I take 1/36 out of 3, I will end up with 2 and 35/36. Okay, but if you're not sure of that, then we can go through that whole borrowing process and so on. And if that's something you struggle with, come see me and we can talk about it further. All right, so at this point, we've dealt with some negative exponents. There are going to be fraction issues in there, so we have to also incorporate our fraction rules. Be careful of that. Anything that you're not sure about at this point, you need to come see me. We need to have a chat one-on-one. So, all right, good luck.